Let's begin. Today's January 7th, 2025, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 5, 9, 11, 16, 21, and 22. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine will let us know if it's an even digit or an odd digit. Criteria card B will take a look at the 3-digit solution, and the Turing Machine will let us know how many 3s there are. Are there no 3s? Is there a single 3? Perhaps 2, maybe even all 3 are 3. Criteria card C will take a look at our first 2 digits, triangle and square, and compare them. So should the value of triangle be less than square? Should they be equal? Or should the value of triangle be greater than square? Criteria card D again takes a look at our 3-digit solution, except this time the Turing Machine will let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card E again takes a look at the 3-digit solution, but this time the Turing Machine will let us know a little bit about its structure. Specifically, there are 2 scenarios. One where the solution has a pair, as in the example 131, or alternatively, there are no pairs, but there are also 2 cases. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F again takes a look at the 3-digit solution from triangle to square to circle, and the Turing Machine will let us know a little bit about the ordering of the digits in the solution. Should the digits appear in an ascending order, meaning that they're increasing, as in the example 135? Should they appear in a descending order, as in the example 421? Or should the digits appear in having no order? So let's take a look at the example of 231. Notice it goes from 2 to 3, it increases, and then goes from 3 to 1, then decreases. Of course, you could have a code that decreases and then increases, but it's that shift from one direction to the other that can exhibit or be explained as having no order. Now, we've seen in other puzzles that there is another scenario, one where if you have consecutive equal digits. So if we take a look at the example in criteria card B, 331, the 3s appear consecutively, meaning that they're next to each other, and of course they're equal. Now the reason I state that that is an example as having no order is for the following reason. When it goes from the first 3 to the second 3, there is no change. It neither increases or ascends, nor does it decrease or descends. So for that fact, I state that consecutive equal digits also exhibit no order. Now remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card A. Okay, so the Turing Machine does not approve of my choice in triangle. I did pick an odd 3, but since the Turing Machine does not agree with that, the Turing Machine is informing us that actually triangle should be even. Well, let's go ahead and type that up in our notes in section A, and we'll state that triangle is an even digit. And since it is even, let's go ahead and cross out the 3 odds. Okay, I think the next thing I'd like to test is criteria card D. Okay, so again, the Turing Machine does not approve of my proposal. Notice that in 314, I do have two odds to a single even. Since the Turing Machine does not agree with that, the Turing Machine is informing us that there should actually be more even than odds. So let's go ahead and type that up in our notes in section D, and we'll simply state that there should be more even than odds. Well, let's see. And basically what that means is that we have at least two evens. So it could be that we have two evens and an odd, or an all even solution. So let's see. What can we say? We do have criteria card B letting us know if there's a 3 or not. Well, since we still don't know if we're dealing with an all even solution, if there's no 3, well, that might mean that there are no 1s or 5s. Or if we can establish that there should be an odd, then it's either a 3 or a 1 or a 5. Now notice also, if you look at the 6 criteria cards, there's no mention of circle. So circle somehow will be forced into some value. It could be that second even, or it could be the odd that we're looking for. So let's go ahead and let's test criteria card C. Okay, so the Turing Machine again does not approve of my proposal. Notice that my triangle is 3, my square value is 1. In my proposal, triangle is greater than square, but since the Turing Machine does not approve of that, it must be one of the other options. And that is that either triangle should be less than square, or they should be equal. So let's go ahead and type that up in our notes in section C, and we'll state that triangle is either less than or equal to square. And because of the equal, I don't think we can actually, let's see, can we cross out anything? Can square, well, let's see, square cannot equal 5, right, in this case. So yeah, maybe we can cross out the 5. Is that true? We want triangle to be either smaller or equal to. Yeah, so I don't think square could be a 5, because if square were 5, obviously again it can't equal it. And well, no, actually, no, yeah, 4 would be less than 5. So no, I am incorrect. I cannot cross out the 5. It's true it can't be equal to triangle, but it is definitely larger than all the other values. I think what I'm looking for is actually 1, that it cannot equal. So yeah, 1 will not be equal to its triangle counterpart, right? Because it's crossed out. And if triangle were 1, there's nothing smaller for triangle to be. So yeah, but now it makes sense. Okay. Let's see, anything else from the other options that we discovered? No, I think that's it. Okay, well, we've completed round 1. We did accomplish testing our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So just as a reminder, we did not query criteria card B, discovering how many threes there are. We are still still need a little work on criteria card C, even though we did test it. We did not test criteria card E, establishing whether there's a pair or not, and we also did not query the ordering of the solution. Well, if you have previously watched these videos, I often leave criteria card E and F in this puzzle, the establishing whether there's a pair and the ordering, towards the second round, because we can actually deduce both of them. That's why I choose not to test them in round one. And so the argument is as follows. If I were to have an ascending solution, and uniquely ascending means that each individual digit is larger than the next, and uniquely, so you couldn't have the same digit. So for that reason, because they are distinct, we would know that that solution would also have no pairs, making criteria card E irrelevant. So if it was ascending, you'd know there would be no pairs. Similarly, if it's descending, it's also decreasing. The digits are uniquely distinct, so again, they'd have no pairs. So we can actually conclude that the solution should have no order. So I'm going to just type it up as we're going to deduce that the solution has no order. Okay, and we can make a similar argument starting off with criteria card E, and that is that if I were to have a pair, either the pairs are consecutive or the pairs would be, the first and last. So as I mentioned at the top of the video, if you have consecutive equal digits, they already exhibit no order. And of course, if the pairs were the first and last, that would mean it would be an increase and then decrease or vice versa scenario. So when you have a pair of digits, that automatically establishes the three-digit code as also having no order, making this card irrelevant. So for that fact, we can also deduce that the solution should have no pairs. So let's go ahead and type that up. We're going to deduce that the solution has no pairs. Now, since there are no pairs and you have a majority of evens, that does mean that you can only have two evens. Because if you have three evens, one of them would be paired up. And let's see, could we, and I don't believe it could be, either 222 or 444, because if that were the case, then we would know triangle would equal square. And that would make criteria card C irrelevant if we had a single digit repeated 3 times. So for that fact, because we're already established we're going to have two evens and an odd, we know that triangle cannot be equal to square. Okay, oops. Yeah, so we can actually establish that no, they cannot be equal. So that means that square has to be larger than triangle. So let's see, can square be 2? Well, if square is to be a 2, then I don't think there's anything smaller for triangle to be. So, no, I don't think square can be a 2. Okay, but it could be a 3 because 3 is larger than 2. And then, of course, 4 and 5 are larger to some extent with respect to triangle 2 and 4. So I think that looks good. And remember that somehow that circle digit is going to be forced into, well, one of the other evens or potentially an odd. And so now that we've established that we are looking for a solution that's 2 evens and an odd, criteria card B now is there a 3 or not? So obviously if there is no 3, it would be forced into a 1 or a 5. Okay, and of course we are also looking for a solution that has no order. So let's see what else. So a little hard to believe, but oh, and I should probably put down here that we're going to we deduced that indeed triangle should be less than square. So I think everything in our notes is very well established. It really just comes down to, is there a 3 or not? So let's see. What if, again, we somehow have to force the issue. And so perhaps, let's see, if square were 5, what would that mean? Could we truly figure out which circle? Well, if square is the odd value and it happens to be a 5, then I don't know if there would be any way to figure out what circle would be. What I'm saying is that possible solutions would be 2, 5, 4 or 4, 5, 2. Yeah, and I don't know if there's any way to distinguish. I think those would all be ambiguous. Yeah, because they'd all be have no order. 2, 5, 4 and 4, 5, 2 have no order. It increases and decreases. So I think for that fact, I'm going to cross out the 5, since it would just produce ambiguous solutions. Okay, now what if square were 3? Well, if square were 3, and we'd have to have no order, that would mean it would be 2, 3, 1, but it fails on 2 counts. 1, we don't have a majority of evens, and it seems like 2, 3, 2 would also fail. So yeah, I don't think, and 4, 3, the only possibility would be 4, 3, 2, and that's descending. So it looks like 3 would also fail. So I think there we have our even digit in square, that's 4, which would force triangle to be a 2. So far it looks like we have 2, 4, and now it becomes whether we have a 3 or not. So let's go ahead and cross out the 2, since we can't have duplicate evens, and we can't have duplicate 4s either, and 5 would just produce a ascending solution, and that's also invalid. So yeah, it comes down to either being 2, 4, 1 or 2, 4, 3, and I don't think there's a way to deduce that. So I'm just going to pick 2, 4, 3, and let's see where that takes us. Okay, so let's go ahead and test criteria card B. And yes, it does approve of a single 3 in our solution. So let's go ahead and type that up. We'll just say that the solution has a single 3. Okay, and so yeah, so that means that 1 is no longer valid. Okay, well, let's type up the solution as 243. And let's go verify. Two, 4, 3. Fantastic. Well, how do we do versus a Turing machine? Well, it is a 6 criteria card puzzle, but we only had to do 4 tests. Amazing. So in the first round, we did A, C, D, all incorrect. And then we tested B in the second round, and that was correct. And we outright deduced E and F. So let's go ahead and type that up. So A, C, D in the first round. A, C, D were all incorrect. And then we tested B, which was correct. And we beat the Turing machine by 2 questions. Well, of course, no doubt, recalling how criteria card E and F interact, knowing that we could deduce those 2. I did, of course, delay that, so I just focused on A through D, and I did choose to ignore criteria card B, but yes, definitely this deduction really helped out. Well, what about you? How did you solve? Did you recall those deductions from previous videos, or did you find something else that you'd like to share? Something I like to refer to as aha moments, when you pick particular criteria cards and proposals and you discover something surprising. Add those thoughts to the comments. If you liked the video, please do give it a thumbs up, and don't forget to hit subscribe. Well, until next time, have a great one.